Hello everyone. In this video I'm going to be talking about phase changes, and then I'm also going to be talking about phase diagrams within this video. So just briefly, what phase changes are, we're going to spend a little bit of time talking about that. So compounds all have the ability to change phases. For instance, you can melt ice, you can evaporate water. They're all water, but you can melt water, you can evaporate water. You can freeze water. You can do the same thing with nearly every compound. I'm sure that there's some weird exceptions in there because chemistry has their weird exceptions. Personally, I don't know of any compounds that you can't do a phase change to. But, you can melt plastic. You can make plastic into a solid. Plastic can actually turn into a gas, I guess, in a way, and go into the atmosphere, and bad things happen with that. But all that being said, all compounds, with possibly some exceptions, not exactly sure if there's some, they all have the ability to change phases. And there's six different types of phases. There's four that we mainly talk about, and there's two that are kind of weird that is not really talked about much because it's not seen very often. So there's melting. The first one is melting, where you have a solid going to a liquid. Again, very easy example of that is with water. You have ice, which is a solid, it melts, turns into a liquid, which is just water. Freezing, another very common one that we see. Great example is water. Again, we're going to use water as an example here, and then when we get to the last few, we'll switch to something else. Freezing, you have a liquid. Let's say you have a water bottle and you put it in your freezer. It's going to freeze and turn into a solid. Vaporization. Vaporization is a liquid to a gas. This is what happens when you are cooking pasta and you have to boil your water, and you see the steam coming up. That steam is, well, steam. It's gaseous water. So it's a liquid to a gas. Condensation is the reverse of this. This is when a liquid is turning to, or when a gas is turning to a liquid. You guys know, again with water, if you leave something cold, the bottle doesn't even have to be water. Let's say you have a Gatorade outside, and it's a cold Gatorade. I enjoy my Gatorades cold, so I like mine cold. But if I'm drinking it on a hot and sunny day, you're going to get condensation on the side of it. And what that condensation is, it's actually gaseous water, aka vapor, in the atmosphere, condensing on your cold water bottle, or cold Gatorade bottle, or cold whatever you're drinking bottle. So that gas from the atmosphere is turning to a liquid. The next two are a little bit weird. It's sublimation and deposition. I hope I'm pronouncing that second one right. I never pronounce things right, so apologies if I'm saying it wrong. But what sublimation is it is when a solid goes to a gas. Great example of this is dry ice. What dry ice is, it's actually carbon dioxide. You don't see dry ice turning into a liquid. Most often it's a solid, and you just see it vaporizing and turning into a gas. We talked about that briefly in class, and I think that's a great example of sublimation, where you have something that's a solid that's turning to a gas. The next one is deposition. I don't have a good example for something that this occurs in, but deposition is when something is a gas and it goes into a solid with no liquid phase in between. So now let's take a look at a practice problem for that. So this is a simple one where you're just matching the phase changes to the names. Try it out yourself. You could even skip this if you're like, I got this, don't have to worry about it. You can skip that and move on. But I'll be going over that now. So when we have something that is a solid to a gas, that is going to be one of our two weird exceptions because there's no liquid phase. But in specifically, a solid to a gas is going to be our sublimation. So I'm going to write C there. I'm going to cross out C. Okay, gas to a liquid. So a gas to a liquid would be an example of something like condensation, right? So let's do that. Did I not write that? What did I write twice? Sublimation I wrote twice. Alright, well, we'll change this to condensation. I knew I was missing one when I was doing this. I was like, something seems wrong. So we'll do that. Next one is a solid to a liquid. So this would be melting. So we're going to put B. Next one, liquid to a gas. This is going to be our vaporization. So that'll be F. The next one is a gas to a solid. That is going to be our deposition. And then finally we have liquid to solid, which would be our freezing. All right. So moving on, let's talk about our phase diagrams. So phase diagrams show us the phases of certain molecules with pressure and temperature. Different molecules and different compounds, they're going to have different phase diagrams, right? Water boils at 100 degrees Celsius. Something like ethanol is going to boil a lot faster than that, boil at lower temperature, not faster, but boil at a lower temperature than that. And then you have something like, sorry, there's a fly in my room. You have something like salt, which is ionic dipole or ionic polar, whatever you want to prefer to call that. It has very, 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 very strong intermolecular forces. So the boiling point and the melting point is going to be very high. So these phase diagrams are different for different molecules and different compounds. So let's take a look at your average phase diagram here. This isn't any one in specific, this is just one that I drew up so that we can get a general idea of what's going on. The first thing I want to look at is what all of these different sections are. This is going to be the same for every single diagram. So, to the right of our first, or to the left of our first line, we're going to have everything over here is going to be a solid, right? So everything to the left of this first line is going to be a solid. Then, everything above what we call the triple point is going to be a liquid above and in between the two lines. So everything in between, you could say the two lines is going to be your liquids. Then everything to the right of all of the lines, so all the way to the right, is going to be our gas. Right, so in every single diagram, it's going to go solid, liquid, gas. Solid all the way to the left, liquid's going to be in between the two lines, and then the gas is going to be all the way to the right. So, also within this diagram, we can look at our triple point and our melting points. So, what melting point and boiling points are is they are the temperature of the melting or boiling at specifically 1 atmosphere. That's what we call the normal melting point. So, when we refer to melting point and boiling point, that's what we're talking about. So, using our phase diagram, we can go up the pressure. By the way, phase diagrams are pressure versus temperature. So, we can go up the phase diagram until we get to 1 atmosphere, and then we go across. The first line is going to be the melting point. So, then we go get down to the temperature. We say, okay, so this is the temperature that the melting point is. Then, to do boiling point, you're going to go all the way across to the second line, and that's going to be your boiling point. The next thing that we can find is our triple point. So our triple point is the point where all of the phases meet. And when you're asked for the triple point, you have to give both the pressure and the temperature, because triple point doesn't have a specific pressure. When we're talking about melting point and boiling point, they're always going to be at 1 atmosphere, so you don't have to mention what pressure it's at, unless it asks. If it says what pressure is the boiling point at, you always will say 1 atmosphere. That's never going to change. Triple points are usually going to change between different molecules and compounds, right? So here we would go across. This looks like it's at about like 0.4 maybe. So we could say pressure of 0.4 atmosphere and then go down. I don't have any gauges here for the temperature, but then you would go down and write down what that temperature is. So that is all you really need to know about the phase diagrams. I think that having just a general picture helps a lot so that you can know what you're looking for within these diagrams. Okay, so I just have 2 examples, problems of these phase diagrams. So the first one says, given the phase diagram, provide the melting point, so we're going to look for the melting point, the boiling point, the triple point, and the phase at 2 atmosphere and 38 degrees Celsius. So let's find that melting point first. Just write out everything that we need, actually, triple point, and then phase. Okay, melting point first. So we're going to go to 1 atmosphere. We're going to move over best that we can, and then move down. So it looks like we're at about, I would say 48 degrees. This is just an estimate. On the test, we may be given like a better graph. Again, this is a graph that I literally just made in like 2 seconds. So your best guess is good. Some people might be like, no, Grace, that's at 50. Your line is not even straight, but I'm going to say 48 degrees. And this is in Celsius. Let me write that here. So this is Celsius and this is ATM. Okay, so the next one is boiling point. Same thing, we're going to go 1 atmosphere. I'm going to move all the way over till we hit that line, and then we're going to go straight down. That one looks like it's at 69. Nice. I didn't even do that on purpose. That's awesome. 69 degrees Celsius. Then the next one is our triple point. So our triple point is where all of those lines meet. And we're going to go across and down. So it looks like here, oh, yeah, we're right. Okay, sorry. This one's going to be at, I would say 39 degrees Celsius. And the atmosphere looks like we're at, oh god, what's in between 0.5 and 1? Oh, 7.5 or 0.75. 0.75 atmosphere. Okay, so now we're going to find the phase at 2 atmosphere and 30 degrees Celsius. All right, so let's go to 38 degrees Celsius, which is about here. I'm going to go up to 2, and because this is all solid here, it's going to be in the solid phase. Wow, I literally wrote that like I was like a first grader. There we go. Cool. So there's your example problem. And then I have a practice problem. You guys can pause the video and try this out. I will be going over it in just a second. Okay, so same process. We're finding the melting point, the boiling point, the triple point, and the phase at 1.5 atmosphere now and 50 degrees Celsius. Okay, so let's go to the melting point. So we're at 1 atmosphere, and then we're gonna go down. This one looks like it's about 55, maybe 56, but I'm gonna say it's just at 55 degrees Celsius. The boiling point, we're gonna keep going across till we hit that line, and then go down. Looks like we're at about 75 degrees Celsius. The triple point, which will be right here, is right at 0.5, we'll say 0.5 atmosphere. And the temperature looks like 35 degrees Celsius. Okay, so now we're going to find the phase at 1.5 atmosphere and 50 degrees Celsius. So we're going to go up 50. Oh, okay. Up 50 and then 1.5. And it looks like we are again at the solid phase. Okay, so that's all that I have for this video. I hope you all enjoyed, and thank you all for watching.